Okay. All right. I guess I'm live. So, uh, the this guy. I just want to see this. Uh, Wait. I just they show a picture of it built.
One of two ways. Either you get something for a huge discount, or you just receive absolute garbage and you question your entire life.
What?
I have no idea where it's going to end up with. This is supposedly a full 3D printer that I paid just 72 euros.
72. Okay. See. Okay. So, what I okay. Let's see here. It's an interesting design. It's actually pretty advanced. I mean, they have so there's the lead screw, but then there's two I wonder if this thing runs G code. I guess that's the belt. Maybe it runs on a belt. I can't really tell what that is.
Disney spent that much money on just a 3D printed model. I think this is going to be at least very, very interesting. The first 3D printer that I built cost over $1,000.
Yeah, so okay, so I'll just say the justification for what I'm doing. I don't want to actually build a 3D printer. I want to build a CNC mill. And I want to build I want to build it to put a little Dremel tool in it. So I guess what I want to know is our Raspberry Pi CNC controller. Right, so but okay, and this just has a bunch of relays. That's not that bad. I'd buy that. That actually takes a lot of the so and you don't even need a Pico because I was thinking like maybe I have to design my own control board that has all this stuff in it. But Pi Linux CNC. Oh, this is not even it's just a GPIO to parallel shield. It's probably like $10 and it's got the breakout, which is great. Um Wait, Linux CNC is an operating system? See, but I need to build the CNC machine. I've never even used Linux CNC. Okay, let's look at this design again.
Not very good. And again, 72 euros, so it fits in that weird middle ground of like not being totally free, but also being eerily close to like an end of free on sale. You can get for like 100, $150. So they're gonna have to cut some corners. So I don't know, is this something we buy just for the parts, or is this something you
Because okay, if um I mean, okay, I guess basically the design requirements is what we're talking about. We're saying how much can we get away with if I'm going to be so ideally I'm just going to be using this to mill PC boards and only the through holes. So you have uh a copper board uh uh yeah, you just buy these. Okay? And the thing is typically these are made with fiberglass, but let's just go to uh inhalation. See, you don't small sharpening can become airborne. You kind of don't want to scar your lung tissue. So but I think you can get paperback double-sided. Here, let's just say this. Where's my can you get double-sided paper-backed PCB copper-clad boards? Uh, why am I? What about paper-backed so it's like less dangerous to mill with a phenolic resin? Toxicity of the phenolic resin. You can see how this model, like text-to-speech model, it's so the structure of our language makes it like easy to do. Uh, dude, yeah, what the hell, bro? I guess you just have to do it. Anyways, I guess we'll just get a shop vac and we'll maybe have to build some sort of enclosure. That sounds terrible. So what's safer, the fiberglass or the phenolic? Safety first, guys. Because I did this, but it just takes so long.
You talking to somebody?
All right. So I guess if you build an enclosure, so we kind of need an enclosure, which sucks. Uh, hmm. I mean, the only one I saw was FR4. All right, so it sounds like we'll just go with FR4 and try to put like a big, even just like a freaking cardboard box around it. I don't know how we're gonna work that out. That seems. I think as long as I don't know. Is okay if let's say we put an enclosure around the CNC mill, just like I don't know, like a big plastic box basically. And I don't know, I guess I guess the question is how much of the fiberglass just stays on the board versus getting airborne. Well, yeah, that's for sure. I mean, I don't even know where I'm gonna put this, but okay, wait, let's just look at, dude. This thing seems so overdone, but I want to watch it.
Generally used as a 3D printer. And
Oh.
again, I have to mention from this part, the AMD Cobra 2 Pro is a full watch to into high speed. Smart pop. See what we got. So this is the Easy 3. I don't know if this is supposed to be Easy 3D or something. The K9 doesn't look like there's a lot in here, but yeah, it's a blue one. That was the cheaper one. It's quite a small package. Isn't that cute? That is the entire print bed, and it looked like this was going to be a heated one. It does have sort of a magnetic surface, but look at that, that is so soft, and it's also extremely light. This obviously is not a heated bed at all. So flimsy. Wow, quick start manual, a full operations guide. That's what you get with a bunch of printers these days. That's the entire power supply. This is 24 watts for the entire machine. 24 watts, that doesn't even cover for the hot end. Wow. Little trash fulfillment, parts. This is all so soft. Interestingly, you get 2 SD card readers. And then this is sort of the entire 3D printer. This is similar to what you
Okay, so see, look at that. That's pretty interesting, actually.
identical axes for X, Y, Z. And I guess these just made him split these together somehow.
Oh, that's fucking awesome, man.
There we go. These just snap together. And I thought, like, hey, this printer sucks. I can still at least use these for like a simple linear axis because the ones on Snapback are all proprietary. You can't drive them outside printer. Oh wow, you can see how far cost cutting measures went because they're not even using like solid rods. They're using tube, and this stuff is, this feels like it's nothing, but I guess it's better than using.
Okay, so even the cheapest, because look, a lot of effort went into designing that thing to be as cheap as possible. It's like actually a marvel. But okay, so you see here, so we have a motor behind a belt, and then see, I'm low key thinking of like how hard would it be to retrofit this? Like that, not it's not crazy to look into. Anyways, the whole purpose is because
I think guys and might straight on those, but yeah, I was wondering like why this thing was gonna be so lightweight. No.
I mean it's actually great. Like why would you need to have a solid rod for something like this?
One thing missing from these mini units, and that's any sort of install. They're using a tiny, like this is less than NEMA 14 size. They're using absolutely minuscule second motor, but there's no install. So I'm guessing to only they just run into the end and let the motor shit. Guess that works. Save some money. And then
Yeah, but can they? I mean, yeah, I guess you can just do that. If you just overshoot anytime you home and you just let it skip, it's kind of jank, but you know, it's I guess it works.
this is for the 3D printer base and the tool head. And the tool head looks, actually, I think that's the best looking part of the entire machine. It looks pretty good. A little silicon socket. You can flip this open. Yeah, it probably just comes straight off.
All right, so we don't really care about the hot end, but I'll watch it.
That's actually kind of cool. So that's the entire hot end and theory. And then, honestly, that doesn't look half bad. I think that take out the silicon sock. There you go. Look at that. It's got a ceramic ring here with a thermistor B sort of on the outside, but that doesn't look too bad. I mean, with 24 watts in total available for the entire machine, they gotta say post.
Yeah, see, there's no way that you could forego a thermistor in the bomb.
Oh, I guess this is, yeah, this doesn't have a lot of mass. It's going to heat up relatively fast, even if it's just a 10 watt hot. It does have a hard cooling fan with a bit of air dive down here. That was probably sort of a separate cooling fan. So that's kind of cool. There's no ability to extrude at all, which is standard practice these days, really. Also, there's more strain in here with the wrap that's sort of captured than a lot of other printers. So that's sort of ridiculous. This thing goes back on. This thing has a clocking. Not that matters. Now, the last thing to look at is this printed base. Obviously, this is also all plastic. This is more buttons than I thought it was going to be. Obviously, this printer doesn't have a screen. There's no way to really interact.
Is he gonna open it up? I really hope he opens it up.
Somehow you are able to put file on print and print by itself, obviously with no way to select which file. This is, I guess, the interface they come up with. Buttons that are like 1 to 4 and 8 play. There's also a switch for feed and retract. And obviously, it also has power and USB, so you can print with it with like Optoprint, which is a printer post on PC. I do want to know what's in here because this looks sort of like a standard mainboard, but that looks like it has Wi-Fi instead of printing on. Okay, let me dig in here. So they do include.
Oh hell yeah!
It's the wrong size. It looks like yeah. I'm gonna bring a proper one. There's another button on the back which has a little home switch. So I guess that's the home switch. So there's 6 buttons on the entire thing. That's quite a lot. So let's see. Oh,
Holy shit!
So standard mainboard that they use for everything, and that they can plug in different communications modules. What I was seeing from the outside was this little print down here, which very much looks like Wi-Fi antenna, but I guess they just plug in different modules here depending on how much interface they're giving the user. So I'm thinking like somewhere on here there must be some serial interface they can just plug into.
Wait, is that that's just an empty board?
Fours or standard.
No, it's just a connector board. But okay, I guess that makes sense.
and 8, which are the Allegro clones, so they're very standard drivers. The tiniest little wires for the hot end. And actually, looking at this, there's a MOSFET for a heated bed, so you could very easily retrofit that if you give it a bit of a more powerful power supply. And in here we've got a
I appreciate how well he did. Well, I'm on my other account.
32 bits, and an AT32F403. That's some sort of STM32 clone. That's pretty cool that you're getting a 30-bit mainboard for $72. That's very nice. So obviously, in terms of like fusing and stuff, there's not really anything in here. But considering we just have a 2 amp, 1 amp, 2 amp, 12 volt supply, I don't think we're gonna need much of that. Power supply is gonna do all the fusing you're ever gonna need. So let's get this thing back together and get it built and get it printed. So you get this quick start guide that is like, new 3D printer user must read the first children level. They're selling this sort of like a kid's toy, but honestly, a kid's toy should be fun. They should be usable. And I'm gonna look at this as if it was a real printer because it has all the parts to one. Yeah, the assembly of this printer is pretty straightforward because it's all just either you clip it in here or you clip it in here, and essentially you just take this part, you slide it this way around, you slide it in here. There we go, that sort of clips in, and then there's one screw in the bottom that they're including.
It's such a beautiful design, man.
It's tightly they're saying, so yeah, okay, that's pretty wobbly, but it's gonna sit on the ground. Somehow it's very light though. And then essentially we just get one cable.
I guess the problem is that this. Like, is that flush with the ground? I would kind of assume it is.
Then
oh fuck!
it's very light though. And then essentially we just get one cable that we plug in, and that's it.
It's 4 cables. Yeah, so it's literally just a stepper motor. It's there's no feedback, obviously.
That's why it's done.
Because I was thinking about my. Does it look like it's hanging off of that thing? It kind of does.
In
any case,
sort of mechanism, so that just slides on the side like so. Ah, crunchy. And then you can just sort of thread one screw straight through the bottom here that locks this in place. But I don't think the screw actually does much because this is already clipped in place.
Okay, so that gives you Y.
Okay. And it looks like they're actually using sort of different connectors for the different parts, so you can't just stack axes onto each other. Like this end connector really doesn't do anything with this side one, so I wish that would have been just a standard connector that you can use to make up your own sort of kinematic stuff. But yeah, like this, and this is just going to fit in the place it's supposed to go. It doesn't click in quite as satisfyingly as the others.
Oh.
Don't want to strip it with just going into plastic. Which way does this go? Like that. Oh yeah, it's fully hand delivered, right? Like that.
That's beautiful, man. Okay, so I guess what I'm thinking also is we kind of want to know the forces applied because I mean, my guess is that the Dremel runs so fast that if you that you're not gonna have any problem.
Stripped. I don't know, it's not very confidence inspiring so far. And then lastly,
Dude, the fact that if I were to build this, bro, it would cost so much more than 75.
the tool head just goes on like that as well. Okay, last screw. Okay, so x-axis goes here, z-axis goes there, and then we get a little filament holder that goes somewhere. That doesn't fit a full-size filament spool, does it? It does. It looks like it's gonna break, but like it does absolutely fit. Where does this go though? Oh, this manual actually is just like 5 pages and then it starts over in Spanish. Okay, put it on and press it down with your hand. Press it down. And then I guess like you're supposed to use that for film. And that doesn't really do much. Okay, so I think
that's funny, actually. Dude, I love how cheap this thing is. It's actually beautiful.
The home button in the back, and you get the 1, 2, 3, 4 buttons here. And those 1, 2, 3, 4 buttons actually move the nozzle to each of the 4 corners of the bed. Because you have...
I really want to know if it runs G-code. No one asks this, dude. Whenever I have a question about a video, it's never in the comments. The comments are always just like, this is the best video I've ever seen. But it's not, you know.
There's manual leveling, there's no auto leveling on this thing, obviously.
And I do that too.
Very convenient. Yeah, I was wondering, like, how do you level this thing? How do you preheat? It's obviously no display or anything, so I have no idea what the printer's trying to do, but it's going to do something. And then that plugs in here. Fan spinning, play button's glowing green. Oh yeah, it is heating, you can smell it. It seems to be heating up. No? Is it? Oh, that's a fan you're smelling. So what if I press home here? Let's see what happens. Yeah, it's doing exactly what I was thinking it was going to do. It just runs into the end and has the motor scale. Yeah, does that work on the z-axis? It does. Okay, I guess we're home. So that means we're already at position 1, so we just need a piece of paper.
That's a tough thing, dude. Actually, being able to home a Z0. Or, what was that exactly?
Feels like absolutely nothing. Okay, I guess we're home. What I was thinking it was going to do. It just runs into the end and has motor scale. Does that work on the z-axis? It does. Okay, I guess we're home. So that means...
See, is it... So does it, I mean, does it just run the Z into the end?
We're already at position 1, so we just need a piece of paper. Looks like absolutely nothing. Let's try 2. Is that the actual usable printer? I don't think so. Why are you so far off? So obviously this is not going to be a heated bed. I have no idea how well this sort of...
I guess I kind of like this design, but it's going to be interesting to design because everything there is injection molded. Quite literally every part is injection molded, which is sweet. It's so sweet. I feel like injection molding is gonna have a is on the come up. So the biggest question for us is definitely going to be how to affix the. Honestly, it's not that hard. It's just gonna be. I guess the only question I have about how I'm going to make sure that that the Dremel tool that's holding the cutter is affixed to the, because if you look at one of those like or like 3D printed drill press or something like that. I knew it. Wait, what? Oh, okay. Uh, yeah, something like this, I guess. Anyways, but this yeah, or something like this. See, that's but what you could do, I remember in the lathe tool, if you look at like a lathe tool head, uh not CNC, bro. Why is all of this CNC? Oh, here you go. If you take, I mean, this kind of, I don't even know what this is, but this lever here stops. It basically pushes a, how does it work? Oh, no, I think it pushes from, how does that work? I'm pretty sure, I'm pretty sure it pushes up into it. Okay.
Super flexible plastic mesh material is going to stick. And then, of course, you end up with little nubbins on the bottom of your parts. But I mean, if it works on an unheated bed, then yeah, I'm going to take every trade off I can. Oh, so when you press 1, it rehomes. Okay. So how do I actually load filament on this? Before feed, you need to make sure there is at least 3 centimeter space between the nozzle and the platform. Press print button and hold for 3 seconds and release. The printer head will raise 1 centimeter each time. That's quite a lot of functionality from just one button. Huh. So like the press and hold to adjust Z on the push machines. Shift the gear, so switch the switch on the side. Blinking fast indicates that the nozzle is heating up. The light turns to blinking slow once it's heated up, and the motor gear starts to turn. So it actually has a filament feed procedure. And then once you're done, just move it back to the center. Okay, let me just get a filament that is a bit brighter than this. I think I'm just going to use the included like 10-meter sample. For these test prints, I think that should be just about good enough. So one thing that's actually kind of cool is that the side of the extruder is just covered with clear plastic, so you can absolutely just see into where the filament is. That's actually pretty well made, I think. I think that the tool head is the best part of this entire machine, obviously. So I'm going to switch this to feed, and then we're blinking fast. So I guess it's just going to start feeding once it's up temperature. There's no.
He's probably not going to like.
Press the button. They could have implemented it like that, but it's just going to keep feeding until you tell it to stop. Now these belts that they're using on all 3 axes, they are minuscule. They're like 3 millimeters wide. They are genuine Gates Power Grip GT though. I mean, at least it says so on the side of the belt. They are properly tensioned, so that's good. We're blinking slowly, and I guess yeah, it's feeding. Oh wow. It is gripping and it is pulling. There we go. There we go. Okay. The smell of cheap perfumed PLA. I guess that's going to cool off again. So hold on. To print something, we're just going to see what's on here. Yep. Okay. That seems to be doing something. What I don't like though is how open everything is. Like all the wiring in the back. This wide wiring, especially this one, gets caught in the bed quite easily. And if you put it underneath, like the print's going to rest on it. So you really don't have a choice but to just have it dangle on the back here. Oh yeah, there's the homing procedure. Okay, that is violent. Okay, it's priming. That looks like the Z height is pretty much spot on. God, actually, I don't know if it's the filament or if it's the hardened stuff just heating up, but it smells horrible. Looks like it is printing with a raft though, so that makes sense considering that you would otherwise have that textured pattern on the bottom of your print. So yeah, it looks like it's printing. I'm gonna catch you all once.
So I think we're going to redesign everything. But I'm going to use this design. You go Y-axis, then you go Z-axis, and then you cantilever the X-axis.
This print is done. It is relatively noisy and it does smell pretty bad, so I'm gonna get out of here. So that's the first print done, and it's not looking as horrible as I was fearing it could. There are some issues where like the feed.
I mean, look at that. If they're getting that kind of resolution, I can build something that's way hackier and be fine. I mean, the layer height looks really small there.
From one speed to another, and here up top it almost looks like a layer shift, but that could also just be overhangs and issues like that. Overall, layers are stacked reasonably well, and you know, this is a good starting point. So that was the pre-sliced G-code, and while I was printing, I had a look at that G-code and tried to replicate it in Crucial Slicer, and we've got a 3D benchy sliced with essentially just lower speeds than usual. You don't have any control of the part cooling fan, so that's just always on. So let's just see how that prints, and that should give us a pretty good indicator of what the strengths and weaknesses of this machine are.
Yeah.
So there's
Dude, I mean, that is incredible. I think, though, one of the things that I haven't thought about is how we're going to do G-code generation, because I obviously want to write a program to generate the G-code. I don't want to... Yeah, well, I'm definitely not handwriting the G-code. That's stupid. So I guess what we'll need is like a mask. I wonder if you can get a copper mask. But okay, yeah, so I guess I don't know if I'm logged in. What is it even called? Easy EDA. Let's see, am I logged in? But okay, sick. All right, so what? Why did I do that? Okay. So I forget which is which. Ah, why is that the only one showing up now? I think it's this one. I mean, this looks pretty good. But did I ever even do a layout? Oh, I did. Okay, so yeah, so what do I want? I want a copper mask. So the thing is, we need to figure out what's up, Stefan. Right now, we're going to try to hop into some CAD. And we're going to try to redesign a version of this that I think anyone could build at home. So what I'm thinking of for bill of materials, 3 NEMA 17s, a Raspberry Pi, and I don't know what drivers. I think just whatever drivers I have lying around. What were they called? I don't remember what they were. But so I guess you can use you can just I've never used Linux CNC, but presumably you can just I don't know. You can do anything. It just takes G code. I just don't know how it works yet. That's something for later. But so I was thinking just to like hash out how we would do the G code generation. Well, we wouldn't want to write something by ourselves because that just seems like way too much work. But presumably there is a way to. Let's see if we can like export. Yeah, like an SVG. I feel like. Yeah. Oh, okay. Here you go. Wait, so I don't want the silk layer. I'll do the board outline, I guess. So this is just gonna be. Oh, okay. All right, let's try it. So if we open this up, obviously it goes to the. Okay, so here you go. So it's this. It's the same as KiCad. So presumably there's an easy way to take this and what is that pin? Why is that pin disconnected? That seems like a problem. Oh, because it's on the other side. Ah, boom. What is that? Oh, okay. Guess we got a thick gold trace here. Oh, but you know what? I gotta ask my friend because there's a second step to this, and it's the what's up, man? It's the thing where you have to because like if I were to cut all of this, I need to do like an inverse thing, but I don't want to. If I invert this, then it's gonna cut forever. It's gonna take like hours and hours and hours to do a single board. So what I need to do is that thing where you like draw a little circle around every edge of the graph. And then you cut that. And in that case it's fine if it overlaps another circle, but it's not fine if the radius of that circle. Oof. I forget how someone yeah. Okay, the G code generation is definitely going to be something to think about. We're going to hop in a CAD in a minute. I'm going to go make a burrito because I'm still hungry.
Just gonna see what's on here. Yep. Okay.
As for a PCB, I think I still have a couple of those metal ones and we could just use that. But for this, I should be able to just use a breadboard. I'm pretty sure everything on this is breadboard. So it's going to be Raspberry Pi, breadboard. But the thing about this is I guess I do need to buy a shield. What is this PCB? Adapter to use a Raspberry Pi's Linux CNC controller. Oh wait, this looks different than...
Hi.
What's up with that music, bro? Okay, so you still need... You still need a, What is this, a power supply? Oh yeah, it is a power supply. I like these stock photos of this display. It's radiating 2 fingers. Okay. These boards, I wonder how cheap of a, like, what's the cheapest CNC board? I want to know. Okay, wait, he has a bomb, so we'll look at the bomb. So, okay, so let's just get this straight. This is the breakout board, so he designed this. Fuck. And I feel like I just order that. 15,000 steps per second max. That's fine. So what is this? So this is his board. Oh, wait, why does he need that? Because, oh, that kind of sucks. Because, oh, I guess it makes sense because I guess he's constrained by this board. I mean, we could just design another board. It's literally just, I don't know why there's sets of 3 here. Oh no, that's 4, but this is 3. Maybe there's 4 pins and 3. I don't know where that goes to. I mean, clear these gotta go to the stepper motors, right? Or I don't see a Duran step set. All right. Well, in any case, we okay. Wait. Oh, geez. Okay. I kind of trust that this works though. Configure the. Okay, so whatever the MOSFETs on the level shifter. Or is it MOSFETs or what are these? Oh, downloaded it? That's great. This is the level shifter or no? No, this is the level shifter. That's so cool that he did all this work. So you need 3 more boards. And then all the rest of the hardware. I wonder if I can... But he... It's a little annoying, actually. I guess it's fine. But why does he say Arduino? I think he just. I mean, this is all because this parallel. Because this is literally Pi LCNC board. Where is that? Wait, this is the level shifter, but we want this. Okay. Do you have the level shifter? Oh, see how compact that is? That's actually so nice. I mean, that drives his whole CNC machine. That's pretty good. So I guess I would order these. I trust that they work, but it's gonna take a while to get here. But well, and see that's the well, but you also need a yeah. What does he use for his? Okay, we need to look at the bomb. Uh, this doesn't say anything. I gotta pee. Get some more food too. All right, I'll watch the video next because he probably says he probably explains what he's using for this. Okay. More food acquired. Absolutely butchered the rolling of this burrito. But I don't give a fuck. Mm.
Oh, my.
Oh fuck. What the hell?
Hi, Chris here with another project concerning my CNC router. Until now, my router was controlled by a modified PC running Linux CNC. This thing was rocking an Intel Pentium CPU, which was already obsolete when I built the machine years ago. Now it seems to lose the last little bit of life left in it, so I needed to look for a new solution. Since I grew to like Linux CNC, I wanted to be able to use that G-code interpreter. This meant that the system needed to run Linux as an OS. In addition, I wanted to design a solution that is cheap and a lot more compact than my old one. That looked like a pretty clear-cut task for a Raspberry Pi, especially since those things got really powerful in the last 2 generations. After searching the internet for a good little while, going with a Mesa FPGA card appears to be the way to go for the envisioned Linux CNC user. These things seem to be a pretty decent choice if the Linux CNC forums are anything to go by, but on the other hand, I can't see a reason to use an FPGA to control the router, since the Raspberry already has 27 GPIO pins to do that. Also, I wasn't able to find good documentation on those Mesa cards in combination with the Raspberry, so I decided to roll my own solution. How hard could that be? First, you would need. So I decided to roll my own solution. How hard could that be? First, you would need some kind of display. In order to keep the whole unit compact, I decided to go with a small LG 7-inch touchscreen. So let's see what our favorite Chinese stuff store has to offer. $35 for a reasonably sized touchscreen looks fine to me. With that out of the way, we now can tackle the electronics part. As we discussed before, the Raspberry provides a good amount of GPIOs. Only problem here is that the IOs operate at 3.3 volt instead of the typical 5 volt used by most CNC.
Dude, this is a great video,
So we
man.
need to fix
Holy.
that with some hardware. Fortunately, there are several IC companies offering chips for just that purpose. Therefore, it should be doable to come up with a lead PCB that handles the conversion from 3.3 volt to 5 volt and the other way around. For controlling the router itself, I intend to use one of those third-gen CNC breakout boards from China. These are basically a bunch of optocouplers, along with some relays and analog outs. It would not be too hard to add that directly onto the custom PCB, but for the price of those things you can't even get the parts. I had also been using one of those things in my old setup, and it worked flawlessly for me. So one of those it is. These boards are intended to be used with a PC parallel port. We could adapt our 5-volt GPIO interface using some custom wiring harness, but that wouldn't look too nice. Since we also need to supply our Raspberry with power, I decided to bake all of that on a second PCB. From the breakout board, we now can control our VFD as well as all the motors on the machine. But I guess for most of us it will
So I
be
guess
a
the
little more
power
than this.
supply is an interesting question.
So much for theory, but let's see what that would look like in practice. I'd say we tackle the easy stuff first. As the base of the whole operation is a Raspberry Pi, we need to prepare an image that is real-time capable. This basically means that the system will respond in a predetermined time. This is kind of critical since we intend to drive our steppers more or less directly with the GPIO pins. For that, we first burn a standard Raspberry image, which is now called Raspberry Pi OS, onto an SD card. Under Linux, you can just use DD, but there are step-by-step instructions for all OSs on the Raspberry homepage. With that out of the way, we activate SSH via placing a file called SSH in the boot directory of the newly burned SD card. This allows us to use an SSH client, such as PuTTY, to access the Raspberry without hooking it up to a screen first. So we should now be able to SSH into our Raspberry by using Pi as a username and whatever IP the Raspberry has in our network. Seems to work flawlessly. The next job on the list is to make that vanilla Raspberry OS real-time capable. Fortunately, the guys at the Linux kernel team did pretty much most of the job already for us by creating the preempt RT kernel patch. It is a little bit of a job to compile that thing though. I found a good step-by-step instruction you should be able to follow with some basic terminal skills. Check the link in the description below. It will take a while, but in the end you will end up with a patched kernel. Now we copy the file onto our SD card. In this case, I did it over the network using SCP. After SSHing into our Raspberry, we prepare the new kernel and switch out the kernel. This whole process is also described in the link below, so I won't bother you with the details. But we need to check.
So you wait, okay. But no, wait, hold on. This was probably before... Because look, in here... See, this video actually is... Oh, this... See, okay, that's interesting. He used that guy's video, or that guy's picture. To remotely... Oh. I mean, it's great that it's got a Wi-Fi chip, right? Oops. In this article, we'll take a look at a general set of instruction bill of materials reference to build a Linux CNC controlled router. See, it says router, but I mean, does it really matter? See, this has an OS on it, but he's doing all this fancy stuff. I forgot how many gigs of RAM mine has. I think I got the most. I think I just got the most. Wait. I think there was a time when the 8 gig didn't work without getting a 64-bit kernel. Memory usage is well under... The builder cornholio and I didn't even notice that. Should transfer to OK as we were using the genuine Raspberry kernel code. One would expect that it will support the Pi 5, but hopefully by changing one variable being the board we are building for. The good news is that our builder has been forked by Linux CNC will become the official Pi image when 2.9 is released shortly. Oh, okay, so I mean this is like decently supported, to be quite honest. Which makes sense. I mean, it's a perfect application. It's written in Python? Oh, goodness. Right. So there is an OS. Or maybe he's like, what does this say? This was July. Okay. Okay, here we go. Similar to setting up other operating systems on the Pi, setting up using Linux CSC is best left to individuals comfortable with the Linux terminal. Referring to the official instructions, download and flash Raspberry Pi OS or Pi OS Lite. It's an ISO. It's that. Wait, what? Oh, is this specifically for Raspberry Pi? Oh, for a complete SD card image is available here. Okay, cool. Wait, but so what is the status of this being on the Pi 5? Does it work? I guess we'll just have to try it. But uh but I don't know enough to say whether or not that's gonna work. Normal download. The normal way. I totally forgot how I actually did this. Just with normal Raspberry Pi OS. Maybe I didn't even do it. No, I did flash it. But I'm pretty sure Rufus is the one that you actually. No, wait, I don't know. Rufus is for. Presumably, someone's made a video about this. Ooh, I actually want to do that. Yeah, we do want to set that up. That's pretty sweet, actually. I never did that, but we definitely want to SSH into it because it's so annoying to have to switch the monitor around. Oh, this is just the GUI. Okay. Oh, wait. Okay, but remote desktoping. Hmm. No. No, I hate when they do that. The freaking topics, that's so stupid. But they never link outside of their own shit. It's so annoying. I mean, this is a good article. Has some people have reported success. That's not very encouraging, honestly. Okay, so it sounds like the best video is definitely.
Out for us. The simplest way
But I guess
to check if the kernel version contains RT in a version name. The tutorial also explains a way to check the real-time characteristics using a cycle time plot. But for the sake of keeping this video relatively short, I will just go on with the next part, which is installing Linux CNC. I did hope to find a repo, or at least a dev package. Unfortunately, I had no luck there, so building from source it is. If you do that on a fresh installation of Raspberry OS, you probably will need to install a whole bunch of dependencies first. Just check the GitHub page and follow the build instructions. Also, by the way, make sure not to do a distro upgrade, since that would reverse all the hard work we just did. Building Linux CNC should be pretty straightforward, if you stick to the instructions from GitHub. I'll also put the link to the repo in the description.
that's how you build it. Oh my god. So it builds a deb. Wait, how did he get that? That's what I don't understand. Did he switch to a monitor or what?
In order to check if that worked, we either need to connect the Raspberry up to some peripherals, or if you're lazy, like me, at least...
No. This is in his normal. That's cool.
Like we got lucky. With that done, the Raspberry is finished for now.
That's super cool.
Okay, next job. As mentioned previously, we still have the issue that the Raspberry speaks 3.3 volts, and our breakout board speaks 5 volt. The typical way to solve that is using a logic lever shifter IC. Since I wanted to keep some...
Oh, but you know what? Are these boards compatible with
outputs in software as they were needed. Regarding the logic lever shifter, I used an NXP part for my first prototype, which you can see here. Although that did work, the ICs got uncomfortably hot, so I changed them to TI ones. Also, we need to supply our Raspberry and the breakout board with power. In order to avoid additional power supplies, I put a DC to DC converter on the PCB as well. As a first prototype, I did produce PCBs in this form factor. They did work quite well, apart from the hot running NXP ICs. While swapping those, I also decided to split the board up. This made the design a lot more space
Is that KiCad?
Also, I ended up with a simple but flexible logic lever shifter PCB head for the Raspberry, which can be used in all sorts of projects, especially if there is a need to talk to 5V electronics, such as Arduinos. I also put the schematics for that little board up on GitHub in case someone else has a use case for them. You can find a link to the GitHub page in the description. There will also be.
So I guess we want to download the boards and see how much it is to get them assembled and stuff.
Where you can get kits if you don't want to get through the trouble of getting them made yourself. That left me with a second small board that carries the power supply and the adapter for the parallel interface of the breakout board. This PCB will conveniently stack on top of the first one. The second batch of prototypes came out quite well.
Is the pin orientation for a Pi 4 the same as a Pi 5? Because like, where is my chat? What the hell? Firefox sucks so much. Okay. Is the pin orientation of the Raspberry Pi pin orientation? of the Pi 5 the same as the Pi 4 because yeah. Well, that's awesome. So that means that any of the shield boards that work for the Pi 4 should work for the Pi 5. What's up? What's up, Ole? Any shield boards, hats, or GPIO accessories for the Pi 4 will work for the Pi 5. That's so nice to hear. Great. So let's, I guess, clone the repo. Where was it?
The breaker board did fit quite nicely. I printed a simple, quick connect frame to keep the boards in place while still giving me the option to remove it from the enclosure. But before we can go on with testing,
Hardware abstraction layer. Can we just do a little deep dive on this thing? It's got 2K stars, and let's see, how's contribution going? It's about as active, you know. It's pretty cool. Linux CNC, bro. So
we need to configure Linux CNC for our hardware configuration. Unfortunately, that did open a whole nother can of worms, which I did not anticipate. Basically, I ran into two main problems. The first one being the configuration of the GPIOs itself. Linux CNC offers a very configurable way to interface your hardware using the so-called hardware abstraction layer. This allows you to generate, process, and map signals similar to the way you would do in hardware, but in software via HAL files. This system has quite a steep learning curve to it, at least for me. But since I did gain quite a bit of experience using that system over the last few years, I figured it should be possible to come up with something. Unfortunately, I did not really find a lot of documentation for the issue on hand. The only resource I could find was a GPIO driver and a short corresponding demonstration HAL file. Since that is quite hard to find, I will put a link in the description below. Based on this information, I managed to configure the GPIOs according to my hardware configuration. If anyone attempts to do something similar, I gladly provide my HAL file for additional reference. Just comment below. The second issue I did not see coming was the Gmocker Pi, which is in my humble opinion.
I'll be back in a minute. I gotta go for a second. Oh, wait. Wait, this was 6 years ago? Dude, Raspberry Pi is definitely the way to do this, man. Hopefully. So, anyway, Oleg, the plan is to do this. It's to build the smallest CNC mill I can by reverse engineering this. So, I don't know if I want to use belt or lead screw. I don't know. But anyways, the purpose of this whole thing is to build a I want to revive my PCB making, but I don't, because the thing is, I used to do PCB making by hand. Like if we go to oh, really? Hold on. Is it that? Dude, I don't even know my own username. Hold on. Wait. Oh, wait, no, see, that's the wrong one. Oh, wait, I know what to do. Hold on. I'm being stupid right now. Okay. Playlists. We used to freaking, let's see, proto board, dual power supply, integrating PCU and oscillator. This probably has me just shaking my shit. So that's soldering. Oh, this is not.
Take it off, right?
That's not a. Oh, here we go. This is the first time I etched the PC board.
I have an
All right, so this is what you do. Why isn't it loading? Anyways, you can see it down there. You put it in this liquid. But it's kind of a pain in the ass, and because you know it's really corrosive and it's kind of nasty stuff, and it spills, it gets everywhere, kind of burns. Anyways, what you can do instead is you can use a mill to just cut around the traces that you want, and I'm thinking I might still put it in this solution and only drill the through holes. Okay, wait. I gotta go. I'll be back in like I don't know 5-10 minutes. Oh, Jesus. Things always take longer than you expect, right? Okay. Um. So I don't know. I guess we need to get three boards. The level shifter, the parallel port adapter, and whoa, really? I guess it makes sense that that's so cheap. $5? I mean, can you believe that? $5? Holy crap. What about Amazon? There you go. I mean, the cool thing is that it's approaching the cost of just getting it made from. Okay.
The best UI for Linux CNC did not support resolutions lower than 980 by 750. Since all the cheap touchscreens you can get are 1024 by 600 max, we have another task on our hands. But how hard can it be to resize a few icons? Turns out not easy at all. The UI is written for an old version of GTK using Glade. Since I was not able to get the older version of Glade running quite right with
Well, that
CNC
sucks.
dependencies,
That sucks. What else has he done? Where did he go? I guess everyone uses this. They're literally all the same.
I had also been using one of those things in my old.
Let's see. Wait, these aren't stepper drivers. What the hell are these things? What is this? MCP? This is the wrong thing. Oh, this is a DAC. Oh, that's what it is. These are DACs. Okay. Wait, then where are all my... Wait, so I only have 2 stepper drivers left. So maybe I'll get some more. And then... And then I actually want this one. But the thing is, this one is actually... Ugh. Maybe I'll buy that. 55 versus 59. Because the thing is, I want to get rid of the freaking cable. It's so annoying. Oh, it does scale down. Maybe I'll just get 3 of these for 25 bucks. It has less torque, unfortunately. $42 by 40. What was the other one? 38. Yeah, so this is it's so annoying that they don't wait. Oh, that'll work. $32. That's what I want. Like, hopefully it comes with the cable. It's nice to be able to disconnect them. Alright, I think I'm gonna buy that. And these. It's crazy that I bought one of these. Don't buy these. If you're doing little shit, buy something like this. Okay. Yeah, belt-based design. The belt is kind of the weird part, right? Oh, that's an interesting design, actually. That's a better design than what I had. I was going to do this big L bracket, but that's way more efficient. Does it come with the bearing? Pillow bearing block? That's pretty nice design. Is it for a 608? And you just cut it off to where you need it to go? Look, that's pretty nice. The thing is, look, that looks like an Acme thread or something. Pitch 2 mm Acme thread. There you go. I wonder if we were to just whoa. Oh, there you go. Wow, it's so fucking slow. It's actually so slow. What the hell? There you go. Okay, and then presumably you can do that on inside threads or no? Oh, you know what you do? I'm stupid. I always mess this up. There you go. Okay, so it does inside threads too. So I guess we have to play with clearance a little bit, but 8x4, what does that mean? TR 8x8 leads to a T8 brass nut. I don't know what the nut is about. The nut is kind of worse than but this one's $12 for one, but it's got the, I mean, I can just print my own of that, so I don't really care about that. What's interesting is that they do they give you two of them. And then what's the point of the brass nut? I don't even get that. I don't even I don't even Is it multi-start? It might be a multi-start thread. Wait, so how does this work? What is the brass nut for? Honestly, a belt does seem better. So how does that work? Like here, for instance. So in the case of a belt, are those bearings? I don't even know what that is. So I guess this part makes no sense to me, really. So what is that exactly?
Right, that's more than you get with a bunch of printers these days. Right, this is 24 parts. And then this is sort of the entire 3D printer. This is similar to what you get on the Snapmakers, where it's just 3 identical axes for X, Y, Z. And I guess these just, yeah, you can just clip these together somehow. I'm not going to try and do this right now. Well, I will. There we go. These just...
I mean, that's so good. I love that. I wonder if you I wonder if you can get away with that with a 3D printed part.
Snap to. Again, and my thought was like, hey, if this printer sucks, I can still at least use these for like a simple linear...
You know, I've been meaning to actually build some latching mechanisms. So how does that work? Can we look up Mach 3 CNC? What is Mach 3? No, wait. Is Mach 3 the software, bro? I'm pretty sure Mach 3 is the software. Then why is the board named that? What if I look up Linux? Presumably the other one works too. Well, let's go to the other one. The worst thing about buying stuff on Amazon is it never has any documentation. See, wait. See, that's the thing is for my case, AliExpress doesn't work because it just takes so long. Wait, wait, how do you spell hol, bro? Yeah, why am I tripping? Dude, the tab system is driving me crazy. Hollow aluminum rod. See, parts sourcing is such a pain because it's like, what even is this?
Axis because the ones on the SnapMaker are all proprietary and you can't drive them outside the printer. Oh wow, you can see how far the cost-cutting measures went because they're not even using like solid rods, they're using tube, and this feels like it's nothing. But I guess it's better than using like plastic guides and writing straight on those. But yeah, I was wondering like why this thing was going to be
Guide
so
rail.
lightweight.
That's what it's called, guide rail.
Now, there's one thing missing from these linear units, and that's any sort of end stop. They're using a tiny, like this is less than NEMA 14 size. They're using an absolutely minuscule stepper motor, but there's no end stop. So I'm guessing to hold these, they just run them into the end and let the motor skip. Guess that works. Save some money. And then this is sort of the 3D printer base and the tool head. And the tool head looks, actually I think that's the best looking part of the entire machine. This looks pretty good. There's a little silicone sock on it. Oh, can you flip this open? Yeah, the cover just comes straight off. Oh, it flips up. That's actually kind of cool. So that's the entire hot end and feeder unit. And honestly, that does look half bad. I do take out the silicone sock. There we go.
Okay.
Look at that.
So do I really want to start on this thing? Pretty challenging to design, not gonna lie. But let's go to the build again.
To one. Yeah, the assembly of this printer is pretty straightforward because it's all just either you clip it in here or you clip it in here, and essentially you just take this part, you slide it this way around, you slide it in here. There we go, that sort of clips in, and then there's one screw in the bottom of the thing, footing, that you sort of fix this stuff together with. It must be fixed tightly, they're saying, so yeah, okay, that's pretty wobbly, but you know, it's gonna sit on the ground. Somehow it's very light though. And then essentially we just get one cable that we plug in, and that's it. That's the Y-axis done. Then the bed has this same sort of
Why am I? In 3D printers, what kind of belt is used? Those black rubber belts or something. Timing, that's right. Timing belt. So how does that work? How does it move it? Does the thing only connect with one side? I have no idea. Right, rotary and a linear. But is it if the carriage was connected to both sides of the timing belt, then it would try to rotate, right? But it's only on one side that it does, so then it... Wait, how does... I don't get it. Let me look up a video of a timing belt. Oh, okay. I wonder if we can just... we can probably 3D print this part, actually.
Maar zo is dat. Zie je wie sokken wat we hadden voor de deals? De Lego deals?
Ah, ja.
Just so zie je het tanden even dat.
Gewoon fijn. Is dat one and none?
We've got one
Anyway, there's one in, one out.
Okay, so there's that. Then... No, I guess they attach it. Is using belts. What the fuck, dude? What's up with that? What is that? Oh, that's a tensioner? Oh, that's cool. Wait, so let's go back. This video is actually pretty good. That works great. So what is the tooth profile called? Because I wonder if we... Oh, 5 meters? Yeah, so wait, and you're supposed to cut it, right? How do they... Let me just look up GT2. Are they always like... I don't love that wobble. Whatever. How do you... Yeah, how to join it? Dude, whenever you see them... Okay, I guess you can do that. As long as they meet at the right spot. That's great. Very cool. Maybe designing something like that is a better first start. So I think what I'm going to do is I'm going to get some more stepper motors because you can never have enough stepper motors. Get the timing belt. It looks like he 3D printed, but he bought the the GT2. It's so interesting when you have to come up with ideas for geometry like that. Why choose Shinran? Oh, jeez. I feel like maybe I could get away with it.
Next thing we're going to do is we're going to start routing the belt. The belt's going to go in from the outside. So what I'm going to do, I'm gonna make it a little extra long. So I'm going to tighten this up. And basically, when you tighten the zip tie, you want the teeth of the timing belt to mash into each other. That's going to help keep it zip tied.
Bro, what the hell?
Wiggle its way loose. Now I'm going to zip tie it pretty tight. So I'm going to run the belt. And the reason why this is a smooth idler is because it's going to be interfacing with the smooth side of the belt.
Right, you don't need it to be on every
So I'm gonna
surface
use
for
the
sure.
belt to kind of help guide me into the right position.
This is awesome, man. Okay, so I think I'm gonna get the Mach 3 board, the steppers, more drivers, and then the GT2 belt. And then, well, I guess before I end the stream here, we should figure out how do we want to get this. I think what I want to do is I'm gonna clone this. I'm gonna clone this. Tiny CNC. That's what we're gonna call it. Should I call it Pico CNC? Hop on the wave. So I haven't really. I don't even have KiCad on here actually. I'll download KiCad. I have 2 terabytes. It's fine. What the hell? Honestly, KiCad could be a lot better, but it's pretty sick. No way, bro. Oh, oh, oh. Oh, they got $16 and they're asking for this. Hopefully just opened. That's crazy. So we're gonna just try to open the boards. Uh, See, this is why it's actually better if okay. So maybe we have to remake these PCBs, and we'll make Well, I don't know. We'll have to look at the symbols. CAD. Oh yeah, in his video he had some fixtures. See, what are those? Are those the drivers or are these the drivers? I don't understand how to set this up. Is there a good video on a... See, what did he actually... Wait, where the fuck did my videos go? Not that one.
Obsolete when I built the machine.
Is that the touchscreen? Oh wait, no, wait, whoa.
Years ago. Now it seems to lose the last little bit of life left in it, so I needed to look for a new solution. Since I grew to like Linux CNC, I wanted to be able to use that G-code interpreter. This meant that the system needed to run Linux as an OS. In addition, I wanted to design a solution that is cheap and a lot more compact than my old one. That looked like a pretty clear-cut task for Raspberry Pi, especially since those things got really powerful in the last 2 generations. Way to go for the envisioned Linux CNC user. Can't see it do that. Decided to roll my own solution. Compact, I decided to go with for the electronics part. Those operate with some hardware. Therefore, it should be doing. For controlling the router itself, I intend to use one of those dirt cheap CNC breakout boards from China. These are basically a bunch of optocouplers along with some relays and analog outs. It would not be
Right, so I want to know how to use one of those. He doesn't really talk about that, right?
It's finally here. The Pi 5 was used at Dell PC to run Linux CNC to translate the G-code into toggled outputs on the parallel port. It ran a Xylotex driver board to convert the parallel port pins to high current bipolar outputs to the stepper motors. The best thing about this system was definitely Linux CNC. The graphical user interface made it easy to know what the router was going to do. Why did I want to switch to the Raspberry Pi? Let me explain. First, I have always been leery about the longevity of a large personal computer. Lots of items have limited lifespan, including capacitors on the motherboard, the hard drive, fans, and power supply. Using a solid-state solution like the Raspberry Pi without any electrolytic capacitors, mechanical hard drives, or onboard fans is an ideal solution for many years of reliability. Plus,
Wow, I didn't even think about that. That's pretty crazy.
Second, I wanted to upgrade this router with 2 major improvements. The first
Dude, I mean, they're running big shit. They're not just running pussy baby boy shit. They're running real shit. That's a big router.
control. I have always used a potentiometer to control the spindle speed manually outside of Linux CNC. Using the new setup, Linux CNC will be able to control the spindle speed. The second improvement is the addition of limit switches. Using the old parallel port to Xylotex...
So we're not going to be... Oh, that's actually a good question. I guess it's just a matter of... what you hook up to it. Because if the spindle... Because maybe we could, yeah, because if I'm just putting a Dremel tool in there, I really want to just turn that on manually. But that should be fine.
Did not leave many inputs to wire up the limit switches. This machine may be a little bit different than yours, but I think this upgrade is something that can be done to lots of machines. Since I am no longer using the Xylotex stepper driver board, I chose to use some inexpensive stepper drivers from Amazon. I use a 24-volt DC power supply for the steppers, and a 48-volt DC power supply for the spindle. I added a separate 5-volt supply just to power the Pi through the USB-C cable that I cut up so I could screw the cable onto the power supply terminals. I like the idea of using readily available parts whenever possible. The 5-axis parallel port breakout board looked like a great solution for all the limit switch inputs and stepper outputs. It also had a relay that could be used for controlling my spindle. The only thing stopping me from using it was that the Raspberry Pi did not have a parallel port. Well, there weren't many Pi parallel port hats available on the market, so the last option was to make one myself. This is the CNC parallel port hat for the Raspberry Pi. It converts the 3.3-volt I/O pins on the Pi header to 5-volt outputs on the DB25F connector. This board was built and tested to work with a 5-axis breakout board, so it may not work as a generic parallel port for other projects. This CNC parallel port hat also has 2 of its own spindle control means. The first version of this board did not have any way to control the spindle because the breakout board had a relay on it and everything was supposed to work great, right? Well, it turns out that the inductive nature of my 300-watt spindle causes too much kickback voltage, and it welded the relay contacts together after about 3 runs. Since it's kind of a bad thing if your spindle won't shut off, I really wanted a better solution. Looking at the internals of the manual spindle potentiometer that I had been using, it looked like a MOSFET with a high enough current and voltage rating was all that was necessary. In the end, the MOSFET is able to control the speed of the DC spindle, which is much more than I was hoping for with the on-off control that the relay would have provided.
Whoa, what's
Also
up?
worth noting is the 5-axis breakout board has a PWM or analog output that can also tell the VFD how fast to run the spindle. So the hardware exists for both means of control, and it's just up to the software settings to get the job done. I know that the Pi 5 is supposed to have a much higher CPU temperature, so I thought it would be best to get the CanaKit heatsink and fan. Using the included double-sided thermal stickers, I tried putting the heatsink on the Pi 5. After pressing for a few seconds, I noticed that the heatsink was not making contact with all of the chips that it was supposed to make contact with. The main processor is definitely the tallest of the heatsinkable parts.
My phone's dead. I don't. Okay, I gotta ask. What about later? All right. Well, it's stressful for me. Hold on.
So it makes contact with the heatsink just fine. Everything else is not sticking correctly. The heatsink fan also plugs into the Pi 5, but the wires on the fan are not long enough to place the fan off to the side like what is needed when using hats. At first, I thought the fan would include screws or something that the fan could mount directly to the heatsink, but I didn't see any mechanical means of mounting the fan. My plan is to get the Pi 5 running on the router, then revisit the heatsink and fan issue at a later time. A 25-pin cable can be used to connect the CNC parallel hat to the 5-axis breakout board, but I prefer the most compact solution available, so I wanted to plug the breakout board directly into the hat. I did need to unscrew some of the mounting standoffs from the CNC parallel hat so the two would fit together. Also worth noting is that the 5-volt USB power input on the 5-axis breakout board will not be usable. Per the USB specification, it should have been a B-style female plug, not an A female, so I am against it in principle too. The 5-volt to the board will need to be supplied on one of the screw terminals. In order to hold the 5-axis breakout board, I designed a 3-volt
I don't really
board
understand how you hook this up. God damn it.
will need to be supplied on one of the screw terminals. In order to hold
Oh,
the 5-axis
no, now I
board
gotta
board,
private
I
this
designed
video. I gotta private it anyways because of the
This seemed to work
freaking
quite well, and I
chat.
was worried that
Because the
print would
chat
freeze
log
as the
gets
screws would fit.
saved.
But as long as I don't over tighten, it seems to hold just fine. The standard Pi standoffs can screw directly into the plastic. There are specific SD card
hold on.
images from Linux CNC for the Pi 4 and Pi 5.
Jeez.
Make sure you download the correct one. I use the Raspberry Pi images
Wait,
software.
one moment. My
into the
computer
micro SD
needs
card.
to open up.
I installed the assembly
Hold
into
on.
my router's electrical box and powered up.
Okay. Ay, ay, ay. What?
It's not your culture.
Ay, ay, ay. Ay, ay, ay. Wait, so I was gonna get the GT2 belt. Oh, but the boards. We installed KiCad. We were ay, ay, ay. Ay, ay, ay. Wait, and I gotta get all my plugins. Oh, actually, doesn't this have a You gotta go to sleep?
I have to go to sleep. I have to get it tomorrow. I have to write this,
Oh,
6 hours
Jesus.
back.
Okay, so let me just end the stream.
Or you can just keep it on and give me like 3 minutes so we can figure out.